Am I audible?
Um,
Am I audible now?
Yes,
Better?
yes, better now.
Yeah.
Much
Okay.
better.
Okay.
Yeah.
Just pull it a little closer. All right. Good evening, everyone. So, guys, I'll quickly introduce myself. My name is Shiva. My team and me, we are responsible to run the platform of NPCI. Well, NPCI, I don't think we require any other introduction there. One of our prime products being UPI, but of course we are a complete suite. We are running the ecosystem there. So I'll quickly move on. Let's try to define the scale. Now, why scale is important? Because unless we try to understand the scale at which we operate, we'll not be able to move into the infrastructure or let's say platform as such, right? So quickly looking at the August data for UPI precisely. This is not the entire, all our products data, but this is only UPI for reference point. So in August, we achieved, or say we have processed 6.58 billion transactions. Thanks to everyone here, thanks to the ecosystem, thanks to the banks, we have achieved that scale. But those are transactions, right? Now, these transactions, when we convert them into technical API calls, how many of you are tech here? Okay, so I'll try to break this down a bit more. API, Application Programming Interface. Quite a long name. I'll quickly summarize this. It's just a request response. I ask something, I get a response, right? So one such call is called as an API call, right? Now, for one transaction of UPI, approximately we process 20 to 22 API calls, right? So that, when we do the math, comes down to 144.76 billion API calls on SSL. What is SSL? It is encrypted. So there's an extra work that we have to do further to secure your transactions. So it's 144.76 billion API calls that we have processed on our platform in the month of August 2022. And when we convert that to number of requests per second, like as I'm speaking, maybe we are clocking a number more than that. It is 55,800 API calls every second, which is an average spread out on 24 hours. And if we actually look at the peaks, we are touching approximately 110K API calls per second in the peak times of our load. And the ecosystem, who is looking at or who are the consumers are clearly mentioned there. We have our regulators, banks, government, fintechs, and startups, and our boards, which are actually helping us to drive this and the entire ecosystem, of course. Now, I'll try to open up this box a bit more, try to explain how we're able to achieve that scale. But before that, let's try to take a step back and see what is a unit measurement. Now, how do we know that the platform, or say the infrastructure, or say the servers, the network, the architecture, the design, is it fitting the need? Because last year, we saw 100% growth of UPI. And can anyone here try to guess the percentage of capacity planning that we have done? Like, for example, we had 100 servers. How many servers did we try to add to handle the 100% growth of UPI transactions? Anyone would like to take a guess? Even the online viewers, you can put it up in the chat. I can check them out later. We hardly added only 15% of our existing capacity. And 15 as in 15, not 50, only 15%. So let's say we had 100 servers. We added only 15 more servers into the stack, and we were able to handle 100% growth of the transaction. So it's a precise marriage between software and hardware. And how do we know that this marriage is going to be successful? Only by looking at unit measurements, numbers. Before that, let's quickly take a look at the platform foundation blocks. Now, on the extreme left, we have microservices. What do we mean by microservices? Let's say there's one huge task. It is split between multiple members, like a teamwork. Virtualization, one form of, how do I say this? I'm going to go a little more deeper in a slide which is coming up next. But virtualization is a way where we can use one physical form factor as multiple different servers or platforms, or say medium on which you can run your application. NPCI for UPI is using 100% open source. We don't pay any licensing fee. It's purely open source stack, 100% open source stack, including the operating system. We only invest in hardware, and the rest of the software that we develop, and we utilize the open source apps. And the fundamental thought process in our scalability is horizontal scaling. All our applications, including UPI, we call them as a unified code architecture. And our scale, we define it with a term called as BDA, as in billion a day architecture. It's a horizontally scaling architecture. In simple words, let's say for 100 transactions, we require 20. For 110, we might just require 21. So we just add one more node to it, and the application automatically does the job. It's seamless, asynchronous in nature. We don't need any downtime to it. So these are the benchmarks. As I've said, numbers are the key, right? So let's quickly take a look at it. As per RBI's data, we have grown 100% last year. This year, we're still counting. We're expecting more there. But let's do a quick math here. The peak requests per second, as I rounded off, is 110K transactions per second. And the total CPU cores as of today is 2,640. And there's a metric called as CPU clock speed for the business teams, or say the non-technological teams, with all due respect. Clock speed is nothing but cycles per second, frequency, right? And in simple words, how many tasks can a particular processor perform in a given period of time? That's exactly the metric we're trying to put up here. 2.8 gigahertz is a number that I've taken based upon our current inventory or what is running UPI. Average utilization at any given point of time, we are looking at 10 to 15%. So I've put it at 10% because we're trying to benchmark. We're trying to come to a best number. And capacity reservation is 5x. So this is exactly how we were able to scale to 100% demand only by adding 15% of our total inventory. In simple words, we reserve the capacity beforehand because we know the business projections. While we try our best to be accurate, they have bloated up more than expected. Thanks to the ecosystem again, we are quite happy serving. So I did a quick math there, and the minimum benchmark, that's the formula. And if I look at it, for a single core of a processor at a clock speed of 1 gigahertz per second, reserving 5x capacity scale, we are expecting that core to perform 75 transactions, 75 API calls per second. And if I do a dirty math, we are expecting 3.5 transactions to be processed by a single core at a 1 gigahertz processor clock speed. 3 or 4 transactions per second, just a single core at 1 gigahertz. So that's the kind of benchmark that we have already set, and we make our choices based upon that. Now, how do we achieve this scale? Now, as I've said, these are stories coming through. DevSecOps, no more a new methodology. It has been quite a de facto standard that the industry has adopted across the world. NPCI is no different. We have also adopted it. We have everything moving in a seamless manner, like an infinite. Right from the start of planning, coding, development, testing, release, deploy, monitor, and from monitoring whatever metrics we get, we again feed that back into our planning phase so that we can do better the next time. Right. And the practice. The previous slide was talking about our methodology. And what is the practice? Our practice is all about cloud and infrastructure as a code. So I'll take a step back. I'll try to explain what is a cloud for everyone. Everyone must be aware of data centers and bare metal service. Cloud is nothing but just top it up with a couple of APIs again and orchestrate your infrastructure using the APIs as per your instructions or your requirements. That's how we try to define a cloud. NPCI also does have a private cloud. We have a closed source as well as an open source cloud too. And what are the advantages? The advantages are self-service infrastructure and agility, of course. We have an auto-scaling algorithm there. So based upon the demand, our virtual machines can scale. The demand is again converted from transactions to the CPU, memory, disk, and network 4 golden metrics. We have an automatic disaster recovery, which gives us, the cloud gives us that. And lastly, but I'd like to also introduce infrastructure as a code now. Many of us have already seen the cloud journey. It's quite a mature journey out there, the public clouds, thanks to the public clouds out there. They've made it quite a popular go-to skill set in the market. Now, one of the major challenges that these platform teams that they face is, in case of a disaster, how do they rebuild their infrastructure from scratch? Because they don't have a backup of their infrastructure configuration as such. Like, you don't know how many virtual machines are you running unless you have a way to continuously dump your infrastructure footprint in near real time, because infrastructure keeps changing based upon the demand. We're talking about a very dynamic infrastructure there, right? Now, infrastructure as a code typically solves that problem. We are precisely looking at Terraform, Ansible. These are 2 very popular languages or scripting languages that we call. What are they used for? They're used to configure or orchestrate your infrastructure in such a way that you can store your infrastructure footprint in a form of a code in any of your favorite version controls, like it could be GitHub, GitLab, Bitbucket, name it, or you self-host it yourself, put it in SVN, and keep a copy of it. In case of your entire data center goes for a toss, not to worry. All you need to do is just point the same code to your cold site or warm site, point, shoot, and your infrastructure is backed up with the same topology. And then within the next few minutes, using the DevSecOps methodology, your disaster recovery kicks in, and your time to come back, or your mean time to detect and mean time to recover, are as low as possible, which gives you, as a result, the most resilient, reliable, and scalable platforms. This is a bird's-eye view of the NPCI platform, a very bird's-eye view. I'd like to pause here for a moment. I know there's a lot of text, my apologies. That's the best I could fit in for the resolution that I got. And I'm very happy. A person smiling here, looking at it. Yes, it is. That's the best I could. We do? All right, thank you. Thanks. I didn't get your name, sorry. Vignesh. Thanks, Vignesh. So from left to right, I'll try to explain this. I'll try to decode this. Do we have a mic that I can carry onto the screen, please? A handy mic? I'm not a great fan of laser pointers, my apologies. I have shaky hands. Can I get a mic? All right. Let's try to decode this extremely complicated diagram. From the left, I'm talking about an MPLS network and an internet network. Internet, precisely, NPCI is a secure network. We don't just call NPCI as a platform. NPCI is actually a network. We connect all the banks, almost all the banks in the country, and they are connected to us through a secure, private network link, and technically it is called as MPLS. That's the MPLS network, which is landing into our data center, where we have OpenStack, which is our open source private cloud. We have a software-defined network. Now, why am I defining software-defined network? Our network is defined by software, and why am I setting that apart from the cloud is because we have another beautiful piece of engineering there called as Kubernetes, invented by Google, now run by the community. CNCF graduated, and then the rest of the environments, which are driven by the DevSecOps methodology. And the DevSecOps methodology is actually bringing in plan, code, build, test, release, deploy, operate, and monitor. Now on the top, we have the software load balancers and web application firewall, security and availability and scalability. As a service, we have DNS, we have HSMs, which gives us the secure keys or cryptography on demand. I'd like to take a pause here. Any questions on this slide? It's on-prem. It's on-prem. We have an HSM, which is our hardware security module, and we have an internally developed application called a centralized key management system, which happens to be like a soft wrapper or say an API for HSM. So we want to be as agnostic as possible, so we came up with CKMS. No, this is a private cloud. We are trying to make our entry onto the public clouds, but of course we are BFSI. We have compliances, regulations, and guidelines to follow, so we're trying our best. Our Terraform is purely pointed at our private clouds, and yeah, even we use Terraform to use on our non-critical projects or products which are running on the public cloud. No, our HSM is not virtualized. These are hardware boxes, but that is a limitation, as you have said. So that's the reason why CKMS. It's a software, it's an open source software which is horizontally scaling in nature. So what next? So that's what we got. That's how we benchmark. That's how we try to determine what is needed for the next 1 year or 2 years or 3 years, right? But what next? Technology is evolving really fast. Demand is increasing. Can we keep adding more and more service to our inventory? Not really, right? If you happen to see the title slide, you saw data center, NPCI logo. So yes, we are moving into our own data centers, which means one thing what we have to keep in mind is the real estate is now static in nature. It's not on demand, which means we can't keep adding hardware service as many as we want because we can't go rent it out or lease it out from the data center providers. It's our own data center. We are running our own data center, right? Which means the reality is limited. Now we have to power pack more power in less space. And that's quite a challenging problem. And hence, we have an R&D team within our platform engineering team. It's a very small team, actually, a bunch of like 7, 8 folks. What we do is we try to crack what is the next best thing to meet the demand of the ecosystem. So let's try to understand bare metal service versus virtual machines versus containers. Here I'll try not to be tech. Now the bare metal servers are like independent houses. You have your own preferences. You buy your land, you get it designed, you get it constructed as per your choice. Now what is the major disadvantage there? After 5 years, like a person like me, I get bored out. Now I need to renovate. Huge task, huge investment. That's bare metal service for you. Then came virtual machines. By the way, bare metal servers have been there for 30 plus years, to be very precise, 32 now. And then virtual machines, I'm talking about x86 architecture. Please don't quote me there otherwise. Virtual machines is like your apartments where it's a huge building, one huge tower or a couple of towers in which you have your own apartments. Again, these are empty blocks. You get into the apartment, you get your interiors done, you get your furniture, everything done, and then you start living. Again, after 3 years or 5 years, you get bored. Now you need to renovate again. Now lastly, then we talk about containers. Containers are precisely 9 years old. I'm talking about Docker. Docker was introduced. Before that, there were LXDs. Even today, they do exist, but Docker being the most popular, I'll put that into the context. Docker was introduced 9 years back. What are containers? Containers are precisely like service apartments, or let me say hotel. I'll stick to the executive apartments, where you have an executive apartment. Most of it is pretty sorted. You just move in, then you buy a small little stuff, and then you get your job done. You stay there for a couple of months and again move out. That's what we do, right? Like when we're going for an on-site, we're staying in a different country, different city. Now, that's the timeline from left to right. Kubernetes. I just mentioned that a couple of slides back. Kubernetes was introduced by Google around 8 years back. 9 years back it was containers, and 8 years back Kubernetes was introduced by Google. It's an open source. They open sourced it. They carved it out of their popular platform called as Borg, B-O-R-G, Borg. And now it is being operated by the community. Now let's try to understand what is Kubernetes. Now the fundamental difference between a service apartment or say an executive apartment versus a 5-star hotel is in a 5-star hotel, everything comes to you at just a phone call, right? That's what exactly Kubernetes does. Kubernetes orchestrates these containers. Now, what is a container in a technological world? It is precisely a power-packed piece of your software which is running, and it just has what it requires, like the dependencies only. Pretty agnostic, very platform-friendly. You can literally flick that container from one place to another, and there will be zero issues because it knows what are its dependencies, and it is carrying them in a very lean way. And that's Kubernetes. Now, one of the breakthroughs that we are trying to do is Kubernetes generally is topped up on top of virtual machines, like let it be a private cloud or a public cloud. You have your Kubernetes in Amazon. In AWS, we have Elastic Kubernetes, I think. They call it as EKS. And then Azure has AKS, and Google has GKE. They have solved the problem of managing Kubernetes. Now, one big such problem, as the gentleman here asked, we are not on public clouds for our prime applications. No, not for UPI, not for our prime applications, right? Now, how do we solve that in our data center? And hence, we chose the path of putting Kubernetes on bare metals. We are on the path. We are already seeing a lot of success there. Soon there will be a couple of more things happening on that space. One thing is Kubernetes does allow you to add more servers on scale. On demand, how do you do that in data center? Well, that's an open-ended question. We can have an offline conversation on that. While we do have some ideas, we are yet to experiment them, get our hands dirty. Moving on quickly, in the best interest of time, we are also doing some research and development on ARM and GPU processors. I'll quickly try to explain you ARM. The CPU, or say the processor existing on all our mobile phones, is ARM architecture. Recently, the Apple released their M1 and M2 Macs, which are approximately, as per their claim, are 10 times faster than the x86 architectures. I'll not quote names. Which made us think, if on an end consumer laptop where there is so much clutter existing, if the same ARM architecture can complement the server business and can complement, even if we achieve 5x capacity, or say 5x boost in terms of performance, I think we are in a sweet space, because as I've said, we are always trying to reserve 5x capacity for products like UPI. Here I'll stop. Any questions?
So how does the energy factor come in? That's the tech stack that you basically use, right?
You're talking about power or cooling?
No, power.
Or people's energy?
The energy that is consumed in the data center.
Uh-huh.
It's also dependent on what kind of programming language you use.
Yes, yes.
Unfortunately, the language that is out there on the board is probably the bottom list of the energy computation that we chose.
Okay.
So is there any angle that your R&D team is focusing on? Because you said like you're married to the software, right?
Yeah.
And,
Not married to the software. We try to complement software with hardware, and likewise. I mean, it's vice versa too.
yeah. So how are you complementing from that angle? Because the amount of compute that keeps going on, and the amount of the code that we write in this programming language is going to scale. It's also incur a lot of.
Well, I see. Let me just summarize your question. You're saying that we're not using the most efficient languages in open source. Yes, I agree.
For example, Rust and Python.
Right. I'll also include Go in it. I'll include Golang too in it. So let me put it this way. There is a known beast versus unknown angel. That's the exact line that I'd like to use. Now, I'm not calling the language that is already serving us as a beast, but all I'm trying to tell you is there's always a sweeter side to the other side. There's always sweetness. The grass is green on the other side. But trust me, every programming language is hardly a language. So fundamentally, what we believe is, if your algorithm behind your program is right, all you need is a good developer who can write clean code. And when we achieve, or say when we start looking with that lens, probably we don't have that challenge anymore. But I don't deny the fact that there are better languages. I agree. I'm not trying to take you into that conversation. Yeah, I agree.
Took a very nice approach of putting Kubernetes on bare metal servers. So I wanted to know, like I was curious to know if there is any separate R&D that's happening on the software side. Because
Yes, of course.
we are also migrating one of our services, which has a close to like 40,000 APIs. We are moving that from Python to.
Well, I think the power problem is too far-fetched for us right now. Maybe what we would like to look at is, because our scale, or say our demand, is increasing at an exponential scale, and our infrastructure has limited space now, and we're trying to pack more power in less space. Can we also optimize our software to perform better? So previously, as I've said, 75 requests per second per core at 1 gigahertz clock speed. That's the exact number that I tried to put in there, right? What if we can achieve 100 requests per second by optimizing the code? If probably that's a low-hanging fruit, in my opinion. if we can coin that, which actually at NPCI, we do that for all the products day in, day out. And the best part is it is unified code, as I've said, unified code architecture. It's one single common base, code base, or one single common architecture, which is powering all our applications. Let it be UPI, let it be IMPS, let it be RuPay, let it be FASTag, or any other product as such, except for Nash, of course. Nash is a different beast all by itself. Any other questions? Yes, please. Yes, please. We'll have to go product by product. And when you say traffic, may I know you're talking
TPS,
in terms of
TPS.
bandwidth?
Yeah, TPS.
TPS, as I've said, in my first slide, I think my apologies. Let me just quickly take you to that particular slide. There you go. We have already achieved 100K SSL RPS at our peak volumes every day
Okay.
in the month of August.
Fantastic. Yeah, my second question is, I heard some news item like Government of India is planning to provide this similar UPI platform to other countries who wants to, proliferate their digital economy. So in those cases, like they'll have to replicate this private cloud infra there, like in those particular governments. That is your vision?
Well, that's exactly how we tried to coin this particular slide. We are not saying you have to go on a private cloud. We are not saying you have to choose a bare metal. We are not saying you cannot go on a public cloud. We are saying if you can provision, let us say, let's do a reverse math. Let us say your requirement is 1000 TPS. When you're introducing, that's a good number to target, right? Or say 1000 API calls, TLS requests, which is equal to 1000 by 20, let's say, which is 50 transactions per second. If that is the scale that you're looking at, here is the math. You plan your infrastructure yourself.
You just need those 5 points to
Yeah.
size them.
Yeah. So that's why we brought it down to a unit metric. And we said, always try to plan for a 5x capacity, and hence, minimum requirement is 15, best is 75 for a single core operating at a 1 gigahertz clock speed, max. This is x86 processors. Yeah. I'm sorry, sir.
How do you do your scale testing now that it's so large?
We do benchmarks up to 20x. Yeah.
With system that's 10x bigger or what? Just don't understand.
So there are times where we have gone to that extent. It's quite a costly setup, but there was no other choice. Because we are speaking of a scale that's talking in billions. Yeah. There's no other way. There's no second way about it. It's tough. It's not so very cost effective, but we don't have any creative ways unless we want to trust our production or say extrapolation skills, which I don't think is the best way for a system which is contributing directly into the GDP of this country. Yes, please. We are a scale out. It's a horizontal scaling architecture. The rightmost column talks about it. It's a 3-tier. We have an application layer, we have a caching layer, and we have a database layer. The beauty of our architecture is we don't care about databases.
Yeah, good. You don't have front end, micro front end.
We do.
So you use micro front end?
Not a micro front end. We do have a web and an app layer, middleware web app. Yeah, it's there. Standard 3-tier. Yes.
So microservices only in the back end.
Yeah. Any other questions?
Any other questions? We still have time. You've got the opportunity. Please go ahead. I'm liking the interactive session that's going on.
Yeah, so do you face any, based on the current infrastructure that you have, are you facing any technology challenges or business challenges?
Every day.
Okay.
So you basically touch the boundary, it starts and goes.
Yeah, so what are those typical ones, which are affecting like subscribers like us? Like sometimes my UPI transaction does not go through. So did you do any root cause analysis?
Well, we do.
Happen outside NPCI or?
It happens within us. So we do have a complete operations team, technology operations team. I'll quickly try to explain how we do that at a very high level, right? UPI, why is it so unique? UPI is the only four-party model, right? It's a four-party model and it is unique in the world. Otherwise, it was always a tri-party model. Three parties only getting involved in a transaction for money to move from point A to point B. With one more extra leg getting added, the complication, or say the complexity, is on the higher side. So we do tracing on our applications. We have live monitoring systems. We clearly come to know if there is a dip. We have, or we are in the process of embedding a prediction-based algorithm based upon our traffic trend, which is purely heuristic in nature. So we clearly can predict what is our DOD, WOW, MOM, in other words, day on day, week on week, month on month, or even sometimes hour on hour. We clearly know our trends. And one of the major complexities that we fall into is prediction of demand. Sometimes we don't know who's gonna come in and give us a surprise. That's because we are providing the service, or we are a service provider or a product platform or a network to the bankers, or say the banks. Banks have merchants, merchants have customers. The merchants take a call to perform, let's say, a big billion day, or some other fest, or some kind of rush happens in the market, which puts a cascading effect, which comes as a cascading effect to us. Like, for example, whenever there's a cricket match starting up, especially the most popular ones, we are always paranoid. We are paranoid, that's what we say. But that's where exactly our planning comes into picture. We always plan for 5x. So, all right, while we are pretty much insured and assured, we are still paranoid. That's the reason we have an R&D team there.
I have one more question. The banks are into this cloud transformation journey. Some of the banks, majority of the banks actually. Now you have built a private cloud infrastructure. Now they are basically basing it on public cloud. Okay. Now unless you have a public cloud journey also, how do you reduce the latency? Because that will be the final denominator of service, right? Let's say if you have this application in the AWS or Azure, and corresponding with merchant banks also having there, that at least those HSN, those pin block translation, and all those account this thing, it does not have to travel to the on-premise data center.
Right.
So have you thought about that part also?
Yes. We are already thinking on those lines.
For example, Visa also is doing that, right?
Well, yeah, I mean, Visa scale, for a moment, let's keep that aside. Right? I'll try to make it a little more contextual in nature. You're saying that a public cloud connecting to our private cloud will introduce latency. And hence, can we bring our systems a bit closer to the banks if they are on the cloud? Is that how I can decode this question to reduce the latency? All right. We are, in fact, already looking into that. It's been a while that we have already started looking into this journey. For the best reasons, I can't give much information here. But yes, we have identified this as one of the factors that can affect us, because the public cloud transformation is definitely happening, right? And definitely, yes, I hope we'll have some positive news out there. Yes, please. My apologies for the inconvenience caused. I'll try to pass on the feedback to the relevant teams, but let me try to put this up in a different way. Dispute is very contextual in nature. My understanding on business is very less. I'm more of a tech guy, so kindly excuse me if I say something incorrect. I might be wrong at some point of time.
When it comes to the tech team, and the response goes from the tech team, is something that is far lesser.
I'll try to decode this a bit based upon my lean knowledge on fintech, or say financial sector. Dispute is a very contextual situation. And The moment there is a context problem coming into picture, we need human intelligence as of today, unfortunately. And depending upon the product that we're trying to refer to, the more the parties, the more the interactions, and I wish humans had APIs, which can actually help us to move the dispute resolution system into an AI-driven ecosystem. That's quite a bright idea. Any startup enthusiasts here, try your luck there. Thank you. I didn't want to actively say that, but yes, thank you. Yes, please.
Sorry, 110,000 GPS or RPS. What year or what day?
August 2022, last month, just the previous month. I wish this was October first week. I would have given the September numbers. Yes, please. Yeah.
Application, middleware, and then database layers, right?
Right.
So, kind of the security you have implemented
Well,
in all three layers.
a small correction there. Don't take that as the real architecture. I'm not allowed to put that up in the public. But
Yeah.
I've tried to create an abstract layer there. We do have a caching layer, we have a database layer, and we have an application layer. The application layer need not be the way it is looking there. The fundamental thought process of putting up that diagram was to say that all these three different layers are horizontally scaling in nature.
Okay, but
I'll say 10.
my concern was kind of the security implementation you have in
I
each
completely
layer.
agree. I come from an infosec background. I've headed security in the past, platform being my passion. I agree. If you're looking at exactly this way, then yes, it's a huge security breach. But please don't worry. You can use UPI. You're safe. You're safe. You're extremely safe. It goes through almost 4 to 5 different layers of security digitally, and 6 layers of physical security physically at the data center. Yeah.
Okay.
Yes, please.
UPI currently has authentication in terms of OTP. Do you plan to have fingerprint authentication in your future?
I think Beam already has it. I use Beam with a Face ID on my iPhone, so I think if you have a biometric, you should actually update the app. You should see the feature. If it isn't there, then maybe I can catch up with you offline. I'll pass on the messages to the respective companies as far as possible. I'll try my best. I'll try my best. Yes, please.
Do you do something else with your data analysis? Or this is the real-time environment, but what about long-term AI?
We have 3 different teams. One is one being the tech analytics team. The second is a business analytics team. The third is a core data science team, which builds the ML and AI. I think Vishy, my colleague, who was just previous sessions, he was explaining about frauds and everything. And there was a question from the audience, what are we doing on machine learning? We do have 3 different teams. One is a pure technology team. The other 2 teams are consumers of this technology provider. And we are building AI ML platform as well as algorithms. We are writing our own models and we are improvising them day and day.
I guess from an architecture perspective, are you using the same exact core and just having to scale for that? Because when you're running those, it's got to impact your real-time
Our
transactions.
analytics platform is entirely different from what I've shown here.
Okay.
We are trying to build a new one. I'll not steal the thunder from the person, Jay, who is also presenting another session. So I'd request you to attend his masterclass. You might get a little more insights there. His name is Jay Prasad Hegde. Can you please help him?
Sure, I will. Yes, once we are done with this session, I'll in person tell you. Yes.
If it is already done, my apologies, friend. I'll refer you to the online link. You might want to rewatch it. But yes, we are doing something creative there too. We have R&D teams on that.
This is just your real-time.
This is our OLTP, online transaction processing systems. That's what I wanted to coin here. That's our bread and butter.
Thank you.
Are we done? Okay, one more. Cool. You all are really lucky that you're getting to ask so many questions with Shiva sir. And let's make the most of this opportunity. Sir busy रहते हैं, sir मिलते नहीं हैं.
Hi. Unfortunately, joined in very late.
No.
So I just wanted to ask. Sometime back, you just said that you don't care about database layer.
Yeah.
Can you repeat and why? What was the reason and how do you scale the database if you don't like? If you're
I'd like to leave out the last question. If really we could really had a solution there, I would have definitely databases would have mattered. The moment something is bothering you in the tech ecosystem, you need to cut the crap out there. Otherwise, you can't scale, right? So that was a fundamental thought process. Databases, they don't scale horizontally. Yes, there are a couple of them out there. They're trying their best. But I don't think they can meet our expectations. We are quite demanding out there. Look at our scale. Now, will you be happy if your UPI transaction is slow or declines? No, right?
No.
Not me. And hence, we wanted to design an architecture. It's kind of intellectual property of NPCI. Our OLTP application has zero dependency on a database, but it does have a database for insurance layer. Even if the database dies, we don't care. Your transaction will go through. Your transactions are safe. Keep using UPI. Yes, please. Yes, please. Yes. Yes. That's an in-house built tokenization system by NPCI.
Yeah.
We call it as NTS, National Tokenization System. Yeah.
Absolutely. So my question is, how about that UPI transaction, like the one I do, let's say from my mobile? Are you thinking of getting those HTTPS transactions also tokenized?
Well, the point is, what are you trying to tokenize? Why are you tokenizing it off the cards on the first place? Because card numbers are vulnerable. If someone knows your card numbers, thanks to RBI in India, there's a second 2FA there, SMS, OTP, etc. But if we look at the entire ecosystem, card numbers are vulnerable as such. If someone is able to grab your credit card number, and I think guessing year, month, and CVV is hardly a math which can be done on your mobile phone. The processors, the power of your mobile processor is enough to crack that combination. A couple of years back, one of my friend did write a blog on it. I'll try to bring that up. It's called a distributed guessing attack, where you actually take 100 combinations and send them to 10 different payment gateways. So you're never caught in any one of them, but you get to know the right combination.
Yeah, but
you're distributing your attack vector, right?
UPI ID and the pins, that I do through my mobile,
Excellent.
I'm always worried that.
I'll try to connect that for you.
Yeah.
So card numbers fundamentally are vulnerable by design, right? And you can't fix design issues in a day. UPI ID, what is getting exposed there, is hardly like your email address. Do you think sharing your email address is going to make someone or is going to help someone hack your email account easily? No, right? It's the same reference. It's the same reference. UPI has multiple layers of security, as I've said. To register, there is an SMS validation, which means a SIM validation is happening. And then the bank is confirming that back to you. That's how the onboarding happens. And then for every transaction, you are inputting a PIN. The PIN is directly handled by our HSMs. Which means no one in this ecosystem except for the HSM, which is already proven to be the most secure way to store your cryptographic keys, has been implemented. I repeat my statement, you're safe, keep using UPI. And you don't need tokenization for it. Any other questions?
Well, on that note, Shiva sir, many thanks for that strong word of trust. I am not